Okay, so first we're just evaluating some trig expressions. So A tells me what is sine of 7 pi over 6. So this should be review. If I rotated 7 pi over 6, what quadrant does that put me in? The third. What would be my reference angle? 30 degrees. It's a 30, 60, 90. Sine is the opposite over the hypotenuse. So this would be 1 over 2. But because I'm in the third quadrant, sine should be negative. So I've got negative 1/2. Questions? B. We want to rotate negative pi over 6. What quadrant would that put me in? In the fourth quadrant, because it's negative. Right, so negative means I'm rotating clockwise, which would put me here. What would be my reference angle? 30. So we've got a 30, 60, 90. Opposite 30 is 1. Adjacent radical 3. Hypotenuse is 2. Sine is the opposite over the hypotenuse. So it would be 1 over 2. And because I'm in the fourth quadrant, that would be negative, right? All students take calculus. Sine is negative. Okay. Well, that's cool, I guess. Let's do sine of 11 pi over 6. If I rotated 11 pi over 6, what quadrant would that put me in? In the fourth. It's a 30-degree reference angle. It's going to be what? Is it okay with that? What about 19 pi over 6? Where does that rotate to be?
Third.
How do you know it's the third?
Because 7 pi over 6 is over there. Wait.
Why? How?
Because
I like what you're saying.
pi is 6 over 6 pi.
Okay, yeah.
And then you go another pi, and that's 12 over 6 pi.
Okay, so
And then you go another pi, and that's 18 over 6 pi. And then you go one more.
that's good. That's good. You could also think about it. I like your explanation. That's the way I would think about it. The way you were talking about it, you said 7 pi over 6 is over there. If I take part of Marissa's, this is 2 pi, right? So this is one full revolution, 12 pi over 6. And so then there would still be 7 pi over 6 left to get to 19 pi over 6. And so 7 pi over 6, I'm basically back to the beginning after 2 pi. And then 7 pi over 6 puts me in the third quadrant. Any of these are correct. Are there more ways to explain it? Yes. You just need some way to figure out how to get there. I don't care what it is, right? But it is in the third quadrant. It's a 30-degree reference angle. It's a lot of negative 1/2, huh? Now what it wants me to do, plot the ordered pairs from question 1 on the graph shown to the right. Okay, so the first one was at 7 pi over 6. So that's a little bit more than pi, right? And we got negative 1/2 as the y value. So a little more than pi down to negative 1/2. So this would be the first point. Let's see, I did that one in... Well, I should have used different colors. Okay, I'll do this. Okay, what about the next one? Negative pi over 6. That means I'm going left from 0, right? Negative pi over 6 down to negative 1/2. Okay, the next one was at 11 pi over 6. That's just short of 2 pi. Right? Everybody's okay with that? So if I go just short of 2 pi and go down, there's that value. And then 19 pi over 6. But we were explained by Marissa, that's a little bit more than 3 pi, right? 18 pi over 6 is 3 pi, or a little bit more than 3 pi, down to negative 1/2. And so what do you notice about all of those points? They have the same y value, but different x values. So how many different solutions are there to this equation? So mostly everything we've done until this point, we've been finding sine, cosine, tangent of an angle. And we've been given the angle. And we've been asked to find what's the ratio. So like sine, this is the opposite over hypotenuse. Right? It's sine of an angle equals what ratio? We're fixing to flip that. We're fixing to know the ratio and be asked to find what's the angle that gives that ratio. Right? It's using the same unit circle, but it's asking the question a little bit differently. So what could I rotate to get negative 1/2 as the ratio? I could have rotated to negative pi over 6. I could have rotated to 7 pi over 6. I could have rotated to 11 pi over 6. I could have rotated to 19 pi over 6. Are these the only 4 answers? No, I can see a 5th one that I didn't even talk about. Got me negative 1/2. And then if I keep going, that's a problem. Because all of pre-cal, all of algebra most of algebra and most of pre-cal is trying to create functions. What's a function? Where every input has exactly one output. I like to have things, I know exactly what the answer is. I don't want all this, what could be, or could be, or could be. Go back to the vending machine answer. I like pressing the button and knowing what I get every time. So that's an issue here. So how many solutions are there? I'm going to say a lot. How about an infinite amount? But I'll turn it into Sand Mountain. There's a lot of them.
So there is an infinite amount?
Yeah. There'd be an infinite amount of answers. I can look up what they say. Because if you think those points are going to continue forever. So if you think back to when we found inverses in the fall, does anyone remember what was required to find an inverse of a function? It must also pass the horizontal line test. That's correct, which means it's what? Does anyone remember what the vocabulary word is? You're right. That's the part it is. It has to pass the horizontal line test. Okay? That is a one-to-one function. So a function, what was the definition of a function? Every input, x, has exactly one output, y. It passes the vertical line test. So is sine of theta, or sine of x, is this a function? Yes. Every input has exactly one output. It's a function. But is it a one-to-one function? One-to-one means every output also has one input. We can think about passing the horizontal line test. It's not one-to-one. So it is a function. It's not one-to-one. So I can't find the inverse of it. Right? That's what that's what this is right here. This is the inverse sine. So if inverse sine exists, how could we find the inverse if it wasn't 1 to 1? Do you guys remember how did we find the inverse of x squared? We did that in the fall.
We'll get it somewhere.
So finding inverses is a reflection over the line y equals x. That's true. But we couldn't flip this as it was. We had to do something first. Because if I were to flip this over the line, it would not be 1 to 1.
Would it take part of it? Just
Which, huh?
erase part of it.
Yeah. We had to restrict the domain. I wanted to cut out some of the x's that were repeated, so that way I could make it be 1 to 1. So if I restrict this domain and only look from where x is 0 to infinity, now it is 1 to 1. And then I could find the inverse. We have to do the same thing here. I need to restrict this domain so that it will pass the vertical line test and will become 1 to 1. So, how can I do that? Where would I shade to make this 1 to 1? Like how I could erase here? Where would I erase to?
Is this still flipped over y equals x?
It does. It does. But the way I think about it, I mean, that kind of hurts my head to flip it. I mean, you might could visualize it. That's not the way my brain works. The way I think about it is, once I restrict the domain, then it passes the horizontal line test. So I need to narrow down my domain so that I can pass the horizontal line test. So like, this is a good beginning point for us, normally, because that's 0, right? That's where we like to begin our rotation. So if I went from here, where would I have to stop it to make it be 1 to 1? Where?
And then, like,
This is pi.
oh wait,
Could I stop at pi? Is that 1 to 1?
no,
No.
half one.
And I stop here at half pi. So is this 1 to 1?
Yes.
Does it give me every possible output? Look at the y values. What are my y values going between here? 0 and 1. We know sine, what's the range of sine?
Negative one.
-1 to 1. So the range of the original needs to be
Negative.
so that's a bad beginning point. I would like to begin there, but it's not going to work for me because I can't get everything in a 1 to 1 ratio. So if I start backing up, now we start to include those negative y values. And we reach the bottom there. And if I cut it off from here to here, there are never any y's that are repeated. We follow? So I've restricted my domain. Does it actually visit every y value though? Yeah, all the way from -1 to 1. So what is the domain I'm restricting to?
Negative half pi to half.
That's it. Negative pi over 2 to pi over 2. So that is right here, number 5. Restrict the domain of the graph above to give the longest possible interval with no repeated outputs. So my interval is from negative pi over 2 to pi over 2.
So intervals are always in parentheses.
You're right. I'm sorry. those could be the answers. So it should be brackets, not parentheses. Good catch. So now going back to this question. The inverse sign of negative 1/2. That means the ratio needs to be opposite side 1, hypotenuse is 2, and I need a negative output. So on my restricted domain, what is the x value? How much did I rotate? Negative pi over 6 is the answer there. So here's the way I would work this problem. If you just gave me this, okay? I need to know what quadrants is inverse sine defined for. Because inverse sine is only valid between negative pi over 2 and pi over 2. So inverse sine can only happen in the first and fourth quadrants. I need the output to be negative. It's positive in the first quadrant, so it's negative in the fourth. And so then I would think from this angle, the opposite, because sine is opposite over hypotenuse, I know the opposite side is 1. I know the hypotenuse is 2. So what needs to be this angle? It needs to be a 30-degree angle. So how did I get a 30-degree angle in the fourth quadrant? Negative pi over 6. That's my logic through it. If you're not a right triangle trig, then you have to have this memorized on your unit circle, right? If you're going that route.